Hi guys, this is our second part of our waves unit. Before we get into new stuff, let's just review what we should be comfortable with based off our last set of notes. So we need to know that waves involve a transfer of energy, okay? That could be through matter or it could be through space, but it's important to remember that they're transferring energy. We learned about two major types, so we need to know what those two types of waves are and what the difference between them is. We learned about mechanical waves, which require a medium. This is just something that energy travels through. And then there's electromagnetic waves, which do not require a medium. What's an example of each of these? For mechanical, these would be things like water or sound. They need something to travel through. Where electromagnetic waves would be something like X-rays or light, where they are able to travel through space. They don't need a medium. We learned these words called a period and a frequency. We need to remember that a period is how long it takes for one wave to pass, so a period of time. And a frequency is how fast the wave is traveling. If a wave frequency is large, what does that mean about its wavelength? So remember, if I have a large frequency, that means that wave is passing by really quickly. The wavelength would have to be small. Remember that these two words are opposite. The larger the frequency, smaller the wavelength, and vice versa. And then we talked about the Doppler effect. Hopefully you guys watched that YouTube video of the car horn, because that shows a great visual of what this should sound like. But what is this? It's a change in frequency or pitch when the source of the sound is moving. So remember, if the source of sound is moving toward you, it seems to be getting louder, right? And if it's moving away from you, the frequency is getting slower, therefore it seems to be getting softer. We also talked about some certain parts of a wave. So looking at this picture, think to yourself, which of these letters would represent the amplitude? That would be G, okay? The distance from the starting point or the middle to either end would be the amplitude. So it can be from the middle to the bottom or it can be from the middle to the top. That's my amplitude. Which of these letters would represent wavelength? That would have to be J. Remember, it's from one point on the wave to the next identical point. This is a link. It can be from crest to crest, or from trough to trough, or just from identical point to the next identical point. So, kind of already gave this away, but a crest, this would be identified by letter F on this picture, and a trough would be identified by letter H on this picture. And we already talked about what frequency is and what a period of a wave is. So make sure that you are aware of all of these words here. So let's get into some new stuff. We're going to categorize my waves again based off of the way they move. So my first type of today is going to be transverse waves. Here the particles move perpendicular compared to the direction of the wave. So imagine I have a string or a slinky, and this hand here is moving up and down, right? The string or slinky is going to move left and right. It's going to be at a 90-degree angle or perpendicular. So this picture of a wave is what we've been looking at, right? We're kind of familiar with what transverse waves look like, moving perpendicular to the motion. What we really haven't talked about was, are these waves called longitudinal waves? These are where the particles are vibrating parallel. Remember, parallel is same direction compared to the wave motion. So notice I still have different segments of waves, okay? I can see identical parts. So this is where the waves are really close together. And same thing over here, so that would be one wavelength. If this was a slinky, I would move my hands left and right, and the wave would move left and right. So it is parallel. Here's another example of the difference. I always remember it because longitudinal waves, they appear long. That's how I remember it. And transverse waves are tall. That's how I remember the difference. This video is a great visual to show you the actual motion of these two waves. So I'll post this, or it should be in the Google Classroom post along with this video you're listening to, so make sure you watch this video as well. So those are longitudinal versus transverse waves. Let's talk about how waves interact, or how they move. What's their type of motion? There's three different methods, or you guys want to remember. One is reflection. A reflection, you guys see your reflection all the time, right? It's an image of something, but how does it work? It's the bouncing back of a wave once it hits a surface. So if this is my surface, I have incoming light waves, it hits it, and then it bounces back. This is how we see a reflection. What we see color-wise is actually interesting, and we'll talk about a little bit later. But you know, this green leaf, it's green. Why do we think it's green? It's simply because this leaf is reflecting the green light wave. We'll talk about different colors of light. Each of these different colors has a different wavelength, okay? So certain objects are going to absorb, certain wavelengths, while others are going to reflect certain wavelengths. So anything that you're looking at, the color you're observing is just because that object is reflecting that color of light. My next type of motion a wave can make is called diffraction. This is the bending of a wave when it hits an obstacle. So imagine you're in a room. Let's say this side of the room is our classroom. Here's our doorway, and then this is the hallway. If somebody is talking in our classroom, just because there's this wall here, but there's a gap, the people in the hallway should be able to still hear us, right? It's not like this wall completely eliminates the sound from getting through. What's happening here is that the sound waves, they're hitting this and they're bending around this obstacle, allowing them to still pass. So that's why you're able to hear things from a different room, like music. If you're playing music in your kitchen and you're able to hear it in your living room, those sound waves are bending around obstacles in order to still get to your ears. And then I have refraction. This is the bending of a light when it passes through different mediums. So we know that waves travel at different speeds, right? A wave traveling through air might travel at a different speed when it reaches the water. It might slow down. So when this happens, the wave, it actually is bending. Notice it's still going in the same kind of direction, but it bent. This is refraction. If you get a glass cup and you put anything in it, like a spoon or a straw or a pencil, you'll see that the object appears bent, right? But we know that that's not true. What's happening here is that because of the difference of mediums, I have air up here and water down here, the light is bending and it creates this visual for us. So refraction and reflection, they obviously sound very similar, but this visual kind of shows you the difference between the two. Remember, refraction is when it's bending, where reflection is when it's bouncing back. Okay, I also have diffraction, where it is bending around an obstacle. So those three words, you have to remember the difference between them. I wanted to briefly talk about the word opaque and transparent with you guys for a second. So different material, it can be known as opaque, translucent or transparent. And based on this picture, you can kind of see transparent is completely see-through, where opaque, you can't really see through it. Light doesn't really pass it. So what's happening in transparent things? Light is able to go straight through them. Okay, this would be like a window. Light is able to pass through the window to the other side, right? It's just transparent. Where translucent is kind of in between, light is still able to pass through. It can also reflect and it can be absorbed as well. Where opaque things, which are more of a solid color, they're going to absorb more energy than the transparent object, right? That kind of makes sense based off of visually how they look. So just keep in mind that opaque objects are going to have kind of more energy than transparent ones. This video, which is also in our Google Classroom post, has great visualizations of what we just talked about: reflection, diffraction, and refraction. So make sure you watch that one too. The last thing I want to talk about for this section of the notes is what happens when I have waves interfere with each other. So this word interference, maybe you've heard the term in sports, right? If an interference happened, that means something kind of messed with something else. That's exactly what's happening here with my waves. I have two types of interference. I have constructive. This is where the amplitude of the waves combine. When this happens, I have the crest of one wave. It aligns with the crest of another wave. And when this happens, it creates a larger wave as a result. The way that I remember this is this result seems to be a better result, right? It's a bigger wave leading to, I guess, a positive end. You ever heard of constructive criticism? Constructive criticism is supposed to be something positive. It's not supposed to tear you down, it's supposed to help you, right? Constructive interference is that these waves are aligning to get a better result. The opposite of this is destructive. Destructive is not really a good term. It kind of associates with negative things. So what's happening here is that the crest of one wave aligns with the trough of another. And when this happens, it completely cancels out the wave, or at least it lowers it. So remember, constructive meaning positive, destructive meaning negative, and it should help you remember the difference between these two types of interference. This is a example of constructive. My crest is aligned with crest, therefore it gets bigger. Destructive, crest is aligned with trough, and therefore it cancels out. And that should end our wave notes part 2. Again, make sure you email me if any of these topics you are confused about or you have any questions. And also make sure you watch those videos because we can't really do demos, right? Usually I would have demos to go along with this where you guys can visually see, but those videos are kind of taking place of those. So those will be helpful if you watch them. So that's it, and we'll be back soon for notes part 3.